So this is the second part of our lecture on magic squares. In the last lecture we discussed this Turaga Gati method of obtaining magic square. So Turaga refers to horse, so Gati is jumping. So basically, so it is related to the movement of horse as we see in chessboard. So how do we generate magic squares using that technique? So I will quickly recapitulate that and then work out a couple of examples, as if you approach me and then ask me, so it will be convenient to see. So how do we exactly use that method to generate? So we will work out a couple of examples. So we did not have much time in the last lecture. So then I will discuss the properties of the pan-diagonal magic squares. So as has been neatly worked out by Professor Vijay Raghavan, and based on those properties, so how is it that we can easily generate magic squares? So these are the two things that we will do in the first, and then we will move on to the method which has been described by Nārāyana, which is called Samputa. So Samputa basically means sort of putting together. So we may translate it as folding method. Folding in the sense of two squares, so folded like a hand, so and then added. So the elements of two squares, so each of them will have a certain arithmetic progression written down in a particular form. So when we sort of fold them together and add the sum, so we will get the magic square. So this is what is called Samputa method of Nārāyana, and we will do that for Samagarbha squares, and then we will also extend it for Vishamagarbha squares, and then we will work out a couple of examples for 8 by 8 magic squares. That will more or less bring the discussion on magic square to the end. So this is the verse which prescribes this Turaga approach to obtain magic squares. Chaturanga Turaga Gatya Dvaudvau Shredhi Samudbhava Vankau Nyasya Kramotkrameణ cha Koshtaikya Ekantareణ cha Savyasavya Turangamaritya Koshthan Prapurayet Ankaihi Samagarbhe Shodashagriha Bhadre Proktaha Vidhischa Ayam. So Vidhischa Ayam, so this is the rule that has been prescribed. So prescribed to obtain Shodashagriha Bhadre, so magic square having 16 cells, so 4 by 4 Samagarbha. And in fact the last line here he says Iha Samagarbhanam apyanyesham udbhavas chaturbhadrat. So anyesham chaturbhadrat, once you have a 4 by 4 magic square, you can extend it to 8 by 8, you can extend it to 16 by 16. So more or less the process will be similar. So that is what Nārāyana points out. Anyesham udbhavaha chaturbhadrat. So I will work out one or two examples so that this Turaga method becomes clear. So let us start with so we will start with 1 here. So this Turaga, so we have to place, so it is a horse movement, so we have to place 2 here. So what is important to note is Dvaudvau, that is what he says. So pair of 2, so suppose you consider 1, 2, 3, 4, so you just split them into 2 pairs, and then these 2, 1 and 2 will have a Turaga, 3 and 4 will have a Turaga. So not 2 and 3. Suppose I put 3 here, then Turaga will lead 4 here. Then I start with 5. So one thing to note here is, so it will be convenient to have a certain pattern recognition, so that we will be able to very quickly fill the squares. So what we have done here is 1, 2, 3, 4. So this could be thought of, the first movement, so is sort of circular, so you can call it Pradakshina. So this will be very easy if you just have some kind of convention, so that we can be easily filled. So now I take 5. So in this example which I have worked out, so 5 6. So, this is Turaga, then so we move 7 and 8.
Excuse me, the 6 can be put in 3 different places.
Yeah.
6 over there, 6 over
No. See, that is why we have so many forms of 384 forms. So, you choose one particular form. So, this Turaga, so you can have in many ways. So, you just choose one particular form, one jump. So, that is why I am just saying. So, this you can have. So, at the second stage what I have done is these 4 elements. So, all of them I have done this apradakshina kind of thing. So, if you want to call yeah. So, in fact he says there are 2 ways. So, there are 2 terms which he says kramena utkramena savyena apasavyena. So, in fact each one has its own way of generation. So, we will just see 1 or 2 examples so that it becomes evident. One has to play around with this. So, then so you can start with Nayan. So, Nayan, so you place 10 and then move on to 11. So, and then you place 12 here. So, this is the third movement which I had done. So, it is again sort of pradakshina kind of a thing. See, and the fourth, so it should be sort of up pradakshina. So, 13, 14, 15 and 16. So, this you can see 13, 14, 15, 16. So, it is sort of let me start with a different location for 2. So, this Turaga from 1, so it can jump to 4 places. It can either be here, it can be here, so it can be here or it can be here. So, this I try to explain in the morning. So, let me choose some other place for Turaga. So, I start with 1 and then I place 2 here. So, you can place 3 here and then 4 will jump. See, in fact there are 2 things to note in the verse. One is, see, you look at this. So, he says kramena utkramena cha koshtaikya ekantarena cha. So, the 2 examples which I have chosen is ekantara. So, one difference. So, koshtaikya is a possibility when you start with 3 here itself. So, we will do that. See, suppose you take 2 here, you can start 3 here, you can put 3 here and then also you can work out. The Turaga Gati should be for pairs. So, I write it this way. So, 3, 4, then you just take 5, so 5 Turaga, so 6, so then 7, then 8. So, 5, 6, 7, 8. Once again you can see 1, 2, 3, 4 I sort of in this particular thing. So, the first movement was so apradakshina 1, 2, 3, 4, 5, 6, 7, 8. So, this is second movement is so pradakshina kind of a thing. Then so I will start with 9, 10, 11 and then 12. So, this third movement, so 9, 10, 11, 12 is once again apradakshina, and once you do a certain pradakshina the rest will get filled. So, 9, 10, 11, 12, 13, 14, 15, 16. So, this is what he refers to by saying savya apasavya krama utkrama. So, there are 2 things. So, one is this kind of a circular movement clockwise anti-clockwise. So, I will just work out one more example. Instead of working out these examples in the board, so we will work out these examples using the slides themselves, and I will explain them so that we will be able to save time. So, in the previous examples you might have noted that the Yamala Yugalas were placed in a sort of circular and anti-clockwise, anti-circular manner. See, 1, 2, 3, 4, 5, 6, 7, 8. So, and so on and so forth. But in the couple of examples that I am going to show you now, so instead of having these Yamala Yugalas placed in clockwise and anti-clockwise mode, we will have them placed diagonally itself. So, for instance, in this example, if you see 1 and 2, 3 and 4, then 5, 6, 7 and 8. So, similarly, so the rest of the things get filled by moving in southeast, southwest, northwest and northeast direction. For instance, if you look at the last 4 numbers, see 13, 14, 15, 16. So, they are all in the northeast direction. So, assuming this to be the north. The next example that I am going to show you now, here instead of placing 5 and 9 in this position, we are just going to swap them. See. So, 1, 2, 3 remain in the same position, 1, 2, 3 and 4 also remain same. So, instead of placing 5 above, I am going to place 5 here to the left and then the whole thing will be placed. So, if you note in this example, so 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. In between these two examples, you will see that the diagonal elements remain the same. See 1, 13, 16, 4, 1, 13, 16, 4, here 14, 2, 3, 15, 14, 2, 3, 15 and what you will notice is the off diagonal elements. See. So, 7 and 11 they have got swapped here. Similarly, 12 and 8 they have got swapped here, 6 and 10 have got swapped, 9 and 5 have got swapped. So, this if you look at this is the kind of motion that we have for the Yamala Yugalas and the first and the last they remain the same, these two have got swapped. So, I will work out a couple of more examples. These are the previous examples and in the new example you will see that instead of placing 3 here, so I am placing 3 here. So, 1, 2, 3 and 4. As I had mentioned earlier, see having placed 1 and 2, 3 can be actually placed in any of these 3 positions 1, 2 or 3. So, initially we started with see 1, 2 and 3. So, this is Ekantara mode and in the other examples these are all Koshtaikya modes. So, Ekantara basically means one cell in between and Koshtaikya 2 cells are close to each other. See 2 and 3 are placed in such a way that there is no cell in between them. So, here again instead of placing 3 here, I have placed 3 here and 4 has to be placed here. So, notice that all of them are Turaga mode only. See any 2 pairs 1 and 2 are in Turaga, 3 and 4 in Turaga. So, between 2 and 3 we do not see. So, each pair you should start and they should have the Turaga mode. This much has to be ensured. And in this example, so you notice see 3, 4, then 5 and then 6 here, 5, 6, so 7 and 8. And between this example and this example, so I am not going to explain all the details. So, you can see from this example and one thing which is strikingly similar between this example and this example is the following. So, here if you notice 1, 8, 10 and 15, 7, 2, 16 and 9, see these are one and the same 1, 8, 10, 15, 7, 2, 16, 9. So, between this example and this example, so by moving 3 from this side to this side, so you see that what has happened is, so the elements 14, 11, 5 and 4, 14, 11, 5 and 4. So, the elements of rows 1 and 3 are identical, whereas 4 and 2 they have got swapped with each other. So, this row has gone here and this row has moved here. So, this is the difference between these two examples. Similarly, in this example, so 1, 2, 3, 4, instead of placing 5 here, I am placing 5 here. See, between 3 and 5 we are just swapping, and here again you will notice that, so between this and this, column 2 and 4 have got swapped with each other, and 1 and 3 they remain the same. Where
did he apply that?
See, the problem is the following. So, when you place the first element, so you have 1, you have 2. So, now you can place your 3 here, 3 here or 3 here. So, when you place 3 here, so there is a ekantara, one koshthas antara, so difference is there.
And when you place it right next,
So it is not koshthaikya.
that is koshthaikya.
Aikya is sort of in proximity.
Okay.
Yeah. So that is what it is. Okay. Yeah. So we move on to discuss this property. So I just started discussion on this. So property 1 essentially tells that so in the magic squares you choose, so any 2, so columns or rows, see, that is what it says, consecutive rows and columns. So any 2 by 2 sub square, the sum will be 34. So any 2 by 2 sub square, the sum will be 34. This is the first property that needs to be. So and so how many such things one can have? So in fact, so morning I was mentioning that it is 15. So apparently it should be 16. So it was pointed out by Kamala Krittivasan, is it? Okay. So by Professor Kamala Krittivasan was saying, so that it should be perhaps 16. Yeah, it looks like there are 16 such possibilities. So one can have, so once you sort of fold it, see, so you have 2, 1, 2, 3, 4, 5, 6, 7, 8, and then so the center will be 9. Okay. So then all the corners when they sort of fold, so you will have. So the second property is will be extremely useful in constructing this magic square along with the third property. So if you look at the square, so you just add up elements which are alternate across the diagonal. So they will be summing up to s by 2, half the magic sum. So 1 plus 16 is 17, so 6 plus 11 is 17, and you have 12 plus 5 17, and 10 plus 7 17. So this is how it is, 13 plus 4 17. So it will be adding up to s by 2. So this is a very important property. So then we move on to the third property, so which is a very very interesting thing which has been proved by Professor Vijay Raghavan. Here, so he says that the neighbors of the elements are fixed. So neighbors in the sense of along any row and column. So for instance, so if you just take number 16 which appears here, so the neighbors are 2, 5, 3 and 9. So whatever be the configuration in which you arrive at, so these will be the 4 neighbors of 16. So this is true for any element that is in the matrix, okay, in the magic square. So this 2, 5, 3, 9, so once we remember this, then I think we will be able to construct the entire magic square. So along with the earlier property, so I will just work out an example. So you start 1, and then so it says that suppose you choose 16, if you remember the neighborhood of 16. So, the neighbors of 16 2, 3, 5 and 9. So, this can be placed in any way you want. So, these are the 4 neighbors. In fact, this immediately tells you that the number of possible combinations is 384. See, so this neighbor, once it is fixed, so there are 4 neighbors and they can be placed in 4 factorial ways. So, which is 24, and for this number this one can be placed anywhere. So, there are 16 ways, and 16 into 24 is 384. So, it is a very important property which has been worked out by Professor Vijayaraghavan. So, here so it tells you that, see, the sum of any of these 4 blocks has to be 34. So, you have 16 plus 9 25, and so this should be 4. And if you look at, so this and this, so they had to sum up to 17. So, this has to be 13, and this and this has to sum up to 17. So, you can place 14, and all these has to sum up to 34. So, this is 28, sorry 18. So, 18 and 9 27. So, this actually fixes 7. So, on this way we can easily fill the entire magic square. So, this is 5, this has to be 12. So, this way one can just get all the elements fixed.
Sir, how come we know which 2 boxes have to have a sum of?
No, this is true of all elements across the diagonal. Any alternate thing if you choose, so that sum has to be 17. You have to just choose alternate thing, and that has to be 17. That is why it is. Okay. So, this is 2 and this has to be 15. So, one can so this is a very elegant way of working out magic squares. Once you remember for one element, so for one element if you remember the neighborhood, then it automatically fixes, so all the elements of the magic square. See.
So that 16 you can place anywhere, no? The 16 you can place anywhere, right?
So, see, once you fix this one, so it has to be here.
Because of the part diagonal.
Alternate,
Yeah.
yeah. So, if you place your 1 there, of course, if you move. So, what is that? See. So, if you place your 1 here, so 16 will get fixed here. So, now this neighborhood, see, so 2, 3, 5 and 9, so you can place it anyway. So, 2, see 3, 5 and 9, so it moves here, so it will be mapped here.
Is that the only place? For 9 that is the only place?
Yeah, so because it has to be in the neighborhood, the cell, so is mapped here in a torus, so that is how it is.
The arithmetic progression of A and D changes, we have to remember the change, or we can simply interpolate it. Means this square can have other sums also as per the arithmetic progression.
No. See, this is valid for elements with 1 to 16. So, all this that we have said is, yeah, okay. So, Samagarbha magic squares, so suppose we have a 8 by 8. So, this Thakkara Peru, as I was mentioning earlier, has discussed this magic square in his Ganita Sara Kaumudi. So, that is the text. So, it is composed around 1300 AD, and so he prescribes a method by which one can construct 8 by 8 from 4 by 4. So, let us conceive of so this magic square So, initially we start with 1, 2, 3, 4. Okay. So, what you do is you do the same thing, you divide it into 4 by 4. So, 1, 2, 3, 4, 5, 6, 7, 8. So, 9, 10, 11, 12, 13, 14, 15, 16. So, you just fill it like a Turagagati. So, you just fix it. So, these are actually referred to as Yamala Yugalankas. See, so 1, 2, 3, 4. So, Yamala is also 2, Yugala is also 2. So, Yamala Yugala is the term that they employ. So, these Yamala Yugalankas have to be placed like this.
What is the meaning of Yamala?
That is also Dvayam. So, now the next step is, see, one thing which we need to note is, so you moved from left to right, see, and then you move from left to right. So, this has to be kept in mind. Then, so wherever you left, so you left with this, so 16. So, you have to start here in the same 4 by 4. So, 17, 18, 19, 20. So, it will be in the opposite way. So, 17, 18, 19, 20. So, you moved here. So, 21, 22, 23, 24. Fine. Then you start here. So, 25, 26, 27, 28, 29, 30, 31, 32. So, this is the next. So, half of it is filled now. The other half, so is almost identical. So, you stopped here and therefore, you have to start here. Okay. So, 32. So, we came up to this. So, then you start 33, 34, 35, 36.
How did you select the position? Sir, how did you fix 33?
Oh, that is a very interesting question. So, why did I choose to place 33 here having placed 32 there? In order to explain this, so I may have to go back, then choose to explain how we chose to place the elements in a 4 by 4 magic square, which is a much simpler case. So, let us see this example. Here, having placed 1, 2, 3 and 4 in a sort of clockwise direction, I chose to place 5 towards the east of 4. So, having placed 4 here, I just place 5 here, and then, so it goes in Turaga motion 5, 6, 7, 8 anti-clockwise direction. So, and then having placed the 8 here, so once again I moved down, and then 9, 10, 11 and 12 were placed in a sort of clockwise direction. So, I would like you to note the relative positions of 4, 5 and 8 and 9 in the case of a 4 by 4 magic square. Now, we move on to the 8 by 8 magic square. In the case of 8 by 8, so we just have to place 1, 2, 3, 4, 5, 6, 7, 8, all of them in the same clockwise manner, and then in the next step, so we placed 16 here and then immediately 17. So, 17, 18, 19, 20, and this pattern will be followed in all the 4 by 4 sub magic squares which are there in the 8 by 8 magic square. And having placed 32, we are placing 33 here, and then we move on in the same pattern 33, 34, 35, 36 and so on. One thing which you need to note here is, whatever is the role played by 4 and 5 in the case of a 4 by 4 magic square will be played by 16 and 17. Say for instance, in the case of 4 by 4, so 4 and 5 are placed by moving towards the east. In the case of 8 by 8, so this 4 and 5 are same as or mapped to 16 and 17 in the case of 8 by 8. So, having placed 16 here, we move towards the east and then place 17. Similarly, this 8 and 9 in the case of 4 by 4 will be mapped to 32 and 33, So, you can notice that, so we start placing them in almost an identical manner as 4 by 4. So, that is why, so Nārāyana, so in his verse he very clearly said, Iha samagarbhanam anyesham udbhavas chaturbhadrat. See, once you understand the pattern in the case of 4 by 4, then all the multiples 4m type can be constructed by recognizing a certain pattern which will be followed in all the higher dimensional magic squares. This is something which one can play around with various things, and then this is how one gets in magic squares.
That doesn't follow the Turagagati.
Huh?
32.
Everything is placed in Turagagati, and where one should start, so is something which is to be filled in, and then one has to understand. Okay. So, in fact, initially people would have started with Turagagati, and then after this Turagagati one actually finds out the explanation. See how many possible combinations, that is what has been worked out by Professor Vijay Raghavan later. So, that this is the only thing possible, and it will be something derivable from the properties, so which one has to study. Okay, so now I move on to another interesting thing. These are all just Turagagati playing, so you just play around. So, this more interesting thing which has been presented as an algorithm by Nārāyana is the following, which is the Samputa Vidhi. Here he says Samagarbhe dve karye chādaka samyam tayor bhave dekam chādhyabhidana manyat kara samputavaccha samputo jñeyaha. So, kara samputavaccha samputo jñeyaha, that is what I was saying. Samagarbhe dve karye. So, Samagarbha, so refers to magic square of dimension 4m. Okay. So, we can work out examples with, so 4 by 4 and then 8 by 8, but so Samagarbha refers to 4m, dve karye you have to prepare 2 magic squares. So, you have to do that. One is called Chādaka, the other is called Chādya. Chādaka samyam tayoho ekam bhavet, Chādyabhidanam anyat. And then, so Chādya Chādaka is just placing one over the other, one is the coverer, the other is covered, kind of a thing. So, this is what he says. So, Ishtadi Ishtachayanka Bhadramita Moola Pankti Samnyadya. So, morning I was referring to, so the kind of Kutaka equation that you will have once you have S and N. So, A and D have to be determined. Okay. So, Ishtadi Ishtachayankaha. Ishtadi, so this arithmetic sequence which you choose, it is Ishta. So, it can be any number, it can be 0, 1, 2, 3, it can be 2, 4, 8, 9, whatever. So, it should be a simple arithmetic progression which you have to choose. Ishtadi Ishtachaya Ankaha Bhadramita. Bhadramita means limited by Bhadra. So, Bhadra if it is 4 by 4, so you have to just choose a string sequence of 4 elements. So, if it is 8, you have to choose 8. Bhadramita, and it is referred to as Moola Pankti. Moola Pankti Samnya Adya. So, this is all it says. Then Tadvat Abhipsita Mukhachaya Panktischa Anya Parakhya Syat. So, Abhipsita Mukha Pankti. So, this Anya, so is Para Pankti. Parakhya means it is called Para. So, we call one as Moola, the other is called Para. And Abhipsita Mukhachaya, so this is also like that. Abhipsita is desired, Mukha is first number, Chaya is difference, Mukhachaya Panktischa Anya Parakhya Syat. So, for example, we can have Moola Pankti 2, 4, 6, 8, we can have 3, 6, 9, 12, we can choose anything. So, 4, 8, 12, 16, it can be even negative. So, we can start with -2, 0, 2, 4, all that is fine. Parapankti, so is also just anything that you like, 0, 3, 6, 9, so all this Chaya is just. Then Moolakhya Pankti Yogonitam Phalam Parasamasa Sambhaktam. So, Moolakhya Pankti Yogonitam. Moolakhya Pankti yoga is basically sum. So, Moolakhya Pankti, you had a Moola Pankti and you had a sequence, arithmetic sequence. Yoga is sum. Unitam is subtracted. Okay. Moolakhya Pankti Yogonitam Phalam Parasamasa Sambhaktam. Phalam, so it was mentioned earlier, refers to the sum of this magic square. Okay. So, sum is referred to as phalam. So, if you look at this equation, if suppose S is the sum, phalam unitam. See, unitam is subtracted. So, moolakhya pankti unitam. Suppose SM, so 1, 2, 3, 4 is your moola pankti, the sum is 10, and what you need to do is, suppose you want to find out a magic square whose sum is 40, so then S minus SM is what is stated here. And parasamasa sambhaktam, samasa also refers to summation. So, parasamasa, the sum of the para pankti, so tena sambhaktam divided, so it has to be divided. So, this is what it is, and what you get is 5 here in this particular case. Then he says labdhahata parapanktihi. So, this parapankti has to be multiplied by the quotient that you obtained. So, gunajakhya sa bhavet panktihi. So, that is referred to as guna pankti. So, since it is obtained from guna, so it is called guna pankti. So, basically, so we need to construct moola pankti and then we need to have guna pankti. So, with them you will be creating your chadya and chadaka, then you do samputa. So, you will get the desired magic square which is pan-diagonal. So, moola gunakhye pankti ete bhadrardhatastu parivritte. See, so having stated this, so he says moola gunakhye pankti, this moola pankti and para pankti. So, bhadrardhatastu parivritte. Suppose you have a square, magic square, bhadrardha refers to half of it. So, parivritte means they have to be placed in sort of circular form. Okay. So, here, so let us take this example. See, so what you need to do is, so 1, 2, 3, 4 you have to place like this, 1, 2, 3, 4. Okay. Bhadrardhatastu, and then in the other 1, 2, 3, 4, 1, 2, 3, 4. And in fact, later he will say urdhvasthitaihi tadankaihi chadaka sanchadyoho prithak yani tiryak kosthani adye anyatarasmin urdhvagani kosthani. So, adye refers to this chadaka square and the other refers to this chadya square. So, while arranging these numbers, so he says you have to follow a certain pattern. So, you just divide this horizontally and then place them clockwise here. So, clockwise here, anti-clockwise, anti-clockwise. So, in the case of parapankti, so you have to divide it this way. So, when you deal with the parapankti and its guna, so guna pankti has to be, so here you have to place it vertically, you have to divide. So, and then, so 0, 5, 10, 15, 0, 5, 10, 15, 0, 5, 10, 15. So, this is how they have to be arranged. So, bhadrasyardham, so these are referred to in the verse by kramagaihi, utkramagaihi. So, krama is so a certain pattern, utkrama is the reverse pattern. So, half of them has to be filled this way, half of it has to be filled that way. And here, how do you know that you have to divide horizontally and vertically? So, you can do this operation on this or that, does not matter. So, one of this has to be filled broken horizontally, the other has to be broken vertically. So, it will work out. So, that is what he is saying, tiryak kosthani. Tiryak means, so that which is horizontal, and anyasmin urdhvagani, so that which is vertical. Okay. So, that is why we have shown this way. So, bhadranam iha samputa vidhihi uktaha nrihari tanayena. So, nrihari tanaya, so this is how he describes Nārāyana as son of Narahari. So, nrihari tanaya. Okay. So, we had this so elements placed here. So, 1, 2, 3, 4, 1, 2, 3, 4 and then anti-clockwise. So, we have placed this. So, now you have to do a samputa. The samputa so amounts to, so 3 plus 10, see, so that will be 13, and so this 0 will overlap with the 2. So, and the first element will be 0 plus 2 and the second element will be 5 plus 3, 8, third element will be 15 plus 2, 17 and the last will be 10 plus 3, that will be 13. So, similarly, so 5 plus 1, so 16 and the last element will be, so this 15 plus 1, this actually goes as 16. So, it is a folding. and then at 10 plus 4 you have 14, and then 0 plus 1 you have 1, and the last 5 plus 4 is 9. Okay. So, this is how it is. This is a pan diagonal square. So, this 16, 8, 12 and 4. So, this is 20, this is 20, you have 40. So, you start with 2. So, if you take this pan diagonal 2, then you have to have 11, 18, 9. So, this also gives you 40. Okay. So, obviously all other rows and columns they sum up to 40. So, this is the prescription of Samputa Vidhi which has been given by Nārāyana. Fine. So, all the pan 7, suppose you choose 7, 9, 17, 9 and then 11 and 3. So, these two sum up to 20, these two sum up to 20. So, you have 40. So, this is a pan diagonal. Suppose you choose all these 4, so corner elements, see. So, 2, 19, 6 and 13, see they form a torus, right. So, 2, 19, 6 and 13, so they also sum up to 40. So, this is the kind of prescription which has been given by Nārāyana to get a pan diagonal square of dimension 4 by 4. Okay. So, let us just take one more example. Suppose you say sum is 120, so you can choose Moola Pankti to be. So, it is all Ishta. So, you can start with wherever you want 2, 4, 6, 8, Para Pankti 1, 2, 3, 4. So, their sum is 20, this sum is 10, and what you have to determine is Guna. So, the quantity to be multiplying this Para Pankti. So, S minus Sm by Sp, you get 10, and Guna Pankti is just a product of this Guna and the Para Pankti. So, 10, 20, 30 and 40. So, this has to be arranged as far as one square Chadya square is concerned. So, you just arrange it, see. So, 2, 4, 6, 8, so 2, 4, 6, 8. So, this the top portion, top half of this you arrange in a clockwise manner, the bottom portion you arrange in a anti-clockwise 2, 4, 6, 8, 2, 4, 6, 8. So, you arrange this way, and here you have to divide it vertically 10, 20, 30, 40, 10, 20, 30, 40, so 10, 20, 30, 40. So, here anti-clockwise 10, 20, 30, 40, 10, 20, 30, 40. So, you sum them up. So, you have the square. So, this is Samputa sum. So, you have to remember that 10, see 4 you get 14, and then 20, so 6 you have 26. So, and then you have 40 plus 4 44, and the last column will be 30 plus 6 36. This, so suppose you take, so this 22 and then 16, 38, 44, we can easily see that. So, this is 120. So, all the diagonals and pan diagonals they will sum up to. Okay. So, the same 120 you can choose a different, this is just to illustrate that, see. So, in the say 120 I chose 2, 4, 6, 8 and 1, 2, 3, 4 here, 3, 6, 9, 12, 0, 3, 6, 9. So, it is all just any arithmetic progression will do, okay, and you will be able to get a different magic square. So, whose sum will be this, and then
That multiplier has to be an integer. Or
which one?
this the S minus Sm upon S.
No, it need not be. So, you can take negative thing also, negative number. So, any arithmetic sequence will do. Okay. Now, I move on to the next thing. So, Nārāyana's folding method for 8 by 8 magic square. So, that when he described the verse, he said Samagarbhe dve karye, that is all. So, Samagarbha, when he mentioned, it can refer to magic square of dimension 4m. So, 8 by 8, so the same thing will work out, and he also said Bhadramita. See, the sequence that you have to choose should be same as the magic square's dimension. So, here you have to choose 8 numbers, that is all. So, let us take one simple example. So, this Moola Pankti, suppose the sum is 260. So, I want to construct a magic square, sum is 260. So, you just choose Moola Pankti. So, 1, 2, 3, 4, 5, 6, 7, 8. This Para Pankti, so 0, 1, 2, 3, 4, 5, 6, 7. Okay. So, these simple illustrations have been provided in the text itself, very simple. All that you need to do is, so if you recall, so the sum and Moola Pankti sum has to be subtracted from the sum of the magic square, and then you have to divide by the Para Pankti sum. This is all it is. So, that prescription is same. So, 260 is the sum, which is desired sum, magic sum, and the sum of this has to be subtracted from that. So, divide by the sum of the Para Pankti, and what you get is 8 here. So, this is guna. So, this guna has to be multiplied with the para. See, the advantage in choosing 0 will be, so addition subtraction will become easier. So, when you multiply, so that is the idea of choosing 0, and choosing the small element. So, you can choose a big number also, does not matter, 48, 96, I mean you can choose all that, but then that will not be convenient. So, that is why choose a small numbers. So, then you get this guna pankti. Again the same principle, you have to divide this, so into half. So, place it in a particular way in one half of that, and then in another way in the other half of the square. For instance, here what we have done is you divide this, so into 2 halves, so at this. So, then you place all this, so 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, okay. Right. So, here it is reverse. So, you have to do the anti-clockwise in the other portion, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So, this is how it is placed. So, here, so you have to split it into the other vertically, you have to divide into half. So, and then you have to place, see 0, 8, 16, 24, 32, 40, 48, 56. So, you place it here. So, you have to place it here the same way, and then place it here the same way. So, this half is filled. So, you have to do the other way around. So, you have to do it clockwise here, 0, 8. So, you add them, Samputa Vidhi. So, this 56 plus 4 is 60, then 48 plus 5 is 53, then you take 40 plus 4, so 44. So, this color will help you in identifying. So, this is 32 plus 5 is 37, so and then 0 plus 4, that is all. So, you have got this magic square of 8 by 8 dimension. Okay. So, one more thing I just want to discuss. So, Nārāyana's folding method for odd squares. So, morning, so we had discussed this traditional method, see. So, move along the diagonal, and then so this verses were also discussed, Asha, Pratyasha, so, so all that we did. So, now so here he says Pankti Moola Gunakhestaha Pragvat Sadhye, see almost identical the prescription is. So, Pankti Moola Gunakhye, you have to derive 2 Panktis, Pragvat Sadhye, so like before you have to do this. So, Adimayam Urdhva Panktau Madhyame Kosthake Likhet. So, it is only a question of arranging in a slightly different way. So, in the case of odd squares, so this prescription is same, you have to obtain Moola Pankti, you have to obtain this Para Pankti, and then with them, so he says Adimayam Urdhva Panktau Madhyame Kosthake Likhet Tadadhaha Kramam, so Shishtankan Urdhvatah Kramati Dvitiyadhyasu Tadvati Dvitiyadhyamsya Samlikhet. I will quickly move on to the example. So, let us choose a 5 by 5 magic square, and let us say the sum we want is 65. So, Moola Pankti, Para Pankti. So, 65 minus sum of the Moola Pankti divided by the sum of the Para Pankti, what we get is 5, and the Guna Pankti that you get is, so just multiply this Guna by Para Pankti, you have this. So, now how do you arrange them? So, the arrangement is done this way. See, if you look at the verse, Adimayam Urdhva Panktau Madhyame Kosthake Likhet. Madhyame Kosthake, the middle one. Okay, you start with that. So, Adimayam Urdhva Pankti, Urdhva Pankti, so if you divide at some point, so then all of them will be Urdhva. Adima Urdhva means the top row. Okay. So, in the top row choose the middle one, so and then start. So, how do you start writing? Tadadhah Kramam. Okay. So, you have to just place the sequence one below the other. So, you had the sequence of Moola Pankti, so you arrange them one below the other. So, then you move on to the next one. So, there you have to arrange it. So, one below, see. So, you have to arrange it this way, and then here you have to arrange. So, once you come here, so this will go to this side, so and then this will complete this. So, this is the arrangement that he prescribes. The same will be for the Chadaka square also. See, start with this, so and then you go, so you get, so now you add this. This kind of method, so which has been prescribed here, so does not yield a pan-diagonal magic square, and it can be converted to a pan-diagonal by slightly rearranging this. Okay. So, modification of Nārāyana Samputa for odd squares. So, we choose the same example, and so we arrange this in the same manner. See, this Mula Pankti, so has to be arranged in the same manner, but here when you arrange this Chadaka to obtain this Chadaka square, so what you do is you start with this, but then so you just see the reason that we have here is, see, all the so diagonal elements are the same, and so all that has to be done is to slightly shift it. See, it is a sort of Turaga Gati you start. So, and then place here 0.
But Mula Pankti also seems to be different.
Huh? No, the arrangement in both.
Is both different.
Yeah. Turaga, so Turaga way of shifting. Okay. So, you arrange and then you add that. Yeah. So, you add that, so you will be able to get this. Okay. So, 22 plus 2, so 20 here and then 2, 22. So, now let us see. So, we have so this 14 plus 3, 25, and 6, 17. So, 17 plus 3 is 20, 25 is 45, and this adds to 20. So, you get the sum 65. So, this is a pan diagonal square. So, this Chadya Chadaka generation is identical, but it is only the arrangement. So, one can play around with magic square and then invent something new also. Okay. So, this is all it is. So, this is recreational mathematics. So, with a couple of references, so I will just conclude my talk on magic square. So, this Ganita Kaumudi of Nārāyana Pandita, as I was mentioning, is so the earliest text that is available, so which has a elaborate discussion on magic square. So, it has almost 75 plus verses, so discussing magic square. So, we saw a few verses right at the beginning as to how Nārāyana was so clearly stating so what he wanted to do, and all the preliminaries were mentioned. And so this is the paper which I was referring to, Professor Vijayaraghavan, so on Jaina's magic square, and this was referred to by Professor Srinivas also during his talk. So, Kusuba, so he has taken a couple of chapters of Nārāyana Pandita, so chapters 13 and 14. 13 deals with combinatorics and 14 deals with Bhadra Ganita, so this magic square, and this was his PhD dissertation submitted in Brown University, and Paramanand Singh has also brought out English translation. So, this book Ganita Sara Kaumudi also has a small section, so it does not deal with in great detail, so it does not discuss pan diagonal magic square, but it has a brief discussion on magic squares. And Thakkara Peru, this is the earliest text that we have, and if you note, so Sakhya, so refers to Sharma, Kusuba, Hayashi and Yano. So, all four are friends, okay. So, they have coined a nice term. So, the first two letters Sakhya, so and Professor Srinivas and Raja Sridharan had also authored an article on this. So, these are the references. Okay, thank you.